This is the raw data of a 1960s football match. 22 isolated particles moving across a pitch, governed by individual flair and unstructured movement. At this time, the sport was a landscape of pure systemic chaos. The global football community viewed this style as an unquantifiable art form, something driven by the soul rather than the spreadsheet. Relying on the unpredictable nature of human instinct creates a massive structural flaw. It lacks repeatable consistency, making any success a matter of chance rather than design. To optimize the sport, the pitch had to be managed as a rigid computational system rather than a canvas for artists. Valeriy Lobanovskyi entered the dugout with the credentials of a trained engineer. He viewed football through the strict lens of thermodynamics and applied logic. He partnered with computer scientist Anatoly Zelenzov, forming a unique crossover between elite sports and hard data science. Their first step was installing a massive, room-sized mainframe computer directly into Dynamo Kyiv's training facility to mathematically map the playing surface. The foundational metrics of modern football analytics were programmed on this analog Cold War-era hardware. The Lobanovskyi system began with these axioms: a defined spatial boundary containing 22 interacting particles, bounded by time. Lobanovskyi rejected traditional static player positions, viewing them as a ceiling on overall team efficiency. He mathematically segmented the pitch into 9 distinct geometric regions to measure exactly where his team held spatial dominance. This required creating the universal player, a highly conditioned unit capable of executing tasks in any of the 9 zones without a drop in output. To maintain this structure, the 11 players had to shift continuous single cohesive block, moving in lockstep across the grid. This block-based movement expands internal passing lanes and ensures numerical superiority immediately around the ball. Defensively, this cohesive movement artificially compresses the total playable dimensions for the opponent, reducing their room to breathe. Positional fluidity was an uncompromising mechanism designed for total spatial control. Executing this theory required hard data. The coaching staff tracked every on-ball action manually, feeding the results into the mainframe. They focused heavily on a core defensive metric, intensity of disruption. This calculation measured how quickly and aggressively the team interrupted opponent passing sequences. Lobanovskyi established absolute numerical minimums for this intensity. If the disruption rate fell below the threshold, the system was considered a failure. This historical metric is the ancestor of PPDA, or passes per defensive action, which modern analysts use to measure pressing efficiency. Modern high-pressing traps are a continuation of Lobanovskyi's original analog disruption algorithms. Possession of the ball was tracked with the same clinical precision. Every squad member was graded using the Zelenzov efficiency coefficient. This formula calculated a player's exact value based on their contribution to a continuous sequence of passes. A player's coefficient rose by completing error-free zone entries, successfully penetrating the opponent's defensive lines while maintaining possession. These entries were the prototype for what we now track as progressive passes or deep completions. This system directly correlates to the modern concept of XG chain contribution, measuring involvement in goal-scoring sequences. The system was ruthless. If a player's coefficient dropped below the baseline, they were benched, regardless of their status. Mathematical minimums for squad viability entirely replaced the concept of individual creativity. The 1986 European Cup Winners' Cup final against Atlético Madrid was the ultimate test of this algorithm. Dynamo Kyiv's 3-0 victory was a result of mechanical, algorithmic execution. Their transition speed was pre-calculated. Kyiv absorbed pressure in a mid-block before instantly launching an overload, with neon green vector lines tracing their path through the Atlético defense. During these attacks, players followed a strict data constraint, a maximum limit of exactly 3 touches per player. The synchronicity of the team was so precise that it resembled a pre-programmed simulation rather than a live sporting event. The resulting European trophy confirmed the validity of the engineers' approach. This final established a clear precedent. A synchronized geometric system can systematically dismantle a team relying on instinct. Lobanovskyi's computational principles spread across Europe, forming the backbone of the modern game. Arrigo Sacchi's revolutionary AC Milan block grew directly from these theories on defensive spatial compression. The universal player and positional fluidity became the core of Pep Guardiola's framework. Ralf Rangnick's modern gegenpressing models rely on the same intensity of disruption thresholds developed in Kyiv. The tactical philosophies of these modern giants operate as sophisticated software updates to Lobanovskyi's original operating system. Today's analysts evaluate inverted fullbacks and track XG chains as a matter of routine. Every time these calculations are run, the analyst is operating within the parameters of the 1970s cybernetic football experiment. If a Cold War mainframe unlocked the geometric limits of the pitch 50 years ago, what systemic boundaries are today's machine learning models missing?